Welcome to this session. So in this session, we have been asked to solve a problem using Cauchy's integral formula to carry out this integration, where C is a circle. Now, when we have this means circle with radius a half, centered at 2. Z equals to 2. So we have always to be, the first thing is to interpret the kind of integration or the kind of the contour you are trying to integrate on. So step 1 is to find the poles as solution. So poles, denominator is equated to 0, i.e. z squared minus 3z plus 2 equate to 0. And this quadratic can be written as z minus 1 and then times z minus 2. So which implies z equals to 1 and z equals to 2 are simple poles of f of z. Now, remember f of z is this function z over z squared minus 3z plus 2, which we can write it as just z over z minus 1 and then z minus 2. So once we get the poles, let's see which poles, whether all the poles are within the circle, outside the circle, or one is within, another one is outside. So we do that by sketching. So this, by definition, we have said means the center is at 2. If I call this one 1, 2, 3, 4, 5. So this is the center of that circle. And radius is a half units. So which means then I only need to draw. So this is this would be 1.5, this is 2.5. And our poles, so if I call this Z1, call this one Z2, then you see that of these poles, 0.2 is within, so this way I have Z1, Z2, and then Z1 is outside. So therefore, we only take care of the pole which is within the circle. This which is outside then gives the integral to be 0. So of the two poles, only Z2, which is equals to 2, lies within the circle. Z minus 2 equals to a half. So using this formula, that the integral along C of f of z over z minus a dz is 2 pi I f of a, we evaluate the integral by taking z equals to 2, because that's the pole within the region or within the circle specified. So we have the integral of z over z squared minus 3z plus 2dz. This can be written as the integral z over z minus 1, z minus 2 dz. And now because the interest is to get only z minus 2 to be in the denominator, so we can divide every term in the numerator and denominator by this other linear part z minus 1, or the same language as saying multiply numerator and denominator by 1 over z minus 1. So divide this by z minus 1, divide this one by z minus 1. I'll not have changed the structure of the equation. So this part and this will cancel out. So this will give me integral z over z minus 1 over z minus 2, because this part and this part now will cancel out dz. So which implies that now my f of z is given by z over z minus 1, and my a is given by 2 in this general formula. So therefore, integral of z over z squared minus 3z plus 2 dz along this c will be 2 pi I times f of a is f of 2, which is the same as 2 pi I times, so this is a function, so where is z equals 2, so 2 over 2 minus 1, which will give us 2 pi I times, so this just be 2, and this will give us 4 pi I. So we don't take care, or we don't respect the other pole z equals to 1, z equals to 1 because it is outside the circle. But assuming this radius of the circle was specified, say, was 2, then we'll have this as the curve. So we'll have to also work out the integral with this given pole, z equals to 1, and then the value you get, you add to the value we have for z equals to 2. But because that was not the case, this should be the solution to the specified problem. Thank you.